And welcome to another exciting video, and in this one we'll learn how we can enforce a null check with composable code branching using either. Now in this one we'll be defining the either type and see how it works. Then we'll try it out to enforce a null check and branch our code. Either is defined as a left or right. Now these are two subtypes or subclasses, if you will, of either, and either doesn't actually come into play. It will just refer to one of these two types. So let's go ahead and define these types. So we'll have right over here, and we'll be taking reference from box type that we created earlier. So over here, comment this one out for the moment, and other stuff will remain same. Instead of box, we will call this as right, and here also we'll have right and right. So we have map and inspect, these two elements. Now if I have to make use of this right, what we can do is let's have it as const, and then we'll have result over here. Then we can make use of right of 2, and let's have map on top of it, and we'll say x plus 1. So once we do this and console the result, save this, and over here let's have either. So we'll say node either.js, and on top of that we will be making use of inspect. So here you can see we are getting a right of 3. So what exactly it's doing, it's taking 2 and then adding 1 to it, and then printing out the result over here as right of 3. So whatever value we have in right as input, we are adding 1 to it when we are making use of the map function. Now the right that we will be creating, so let's copy this code piece over here and let's call it as left. Now over here we won't be doing f of x, so we'll be first of all writing left over here, and we will be just keeping it as is, left of x, and that's what we will be printing over here, left of x. Now if I go ahead and make use of left over here, so let's copy this, put it over here, comment out the first piece and make use of left, and now we are saying left of 2, then map x plus 1. Let's run this. Now you'll notice that it's not doing anything on top of it. So when we are just passing 2 and it's just going and saying left of x, that's 2 over here. So whatever top operations we are trying to implement on this type, it's totally ignoring that. So basically left refuses to run any of our requests here. Now why this is useful? To get at why this is useful, we will define our fold here and look at some real use cases. Fold, if you remember from box, removes our value from the type when we run our function. It will drop out of our container type and give us our value back. However, we have two types here. We have a right or a left. Usually we don't know if we have a right or a left. We don't know which one it is. If our fold is going to handle either of these cases, it needs to take two functions. If it is the right case, we will run the second function. So here we will be making use of fold. So as you can see, I've commented this version from box, and we'll have a newer version over here. So in this case, when it's right, we will be running this version, and if it's left, then we will be running this one, the f of x. So that's the difference over here. So now let's see how this is going to be useful. Over here we'll say right of 2, then we'll say map x plus 1, and after that we will be making use of fold. So here I'll be removing inspect and we'll say fold. Now this fold could either be of right or left. So what we will be doing now is we'll say if it's left, then we'll show error, otherwise we'll have of x over here. Now let's save this and execute it. You can see it's getting 3 over here. Now if I put a left over here, let's see what it does. You see it throws an error. Now this allows us to do some pure functional error handling, code branching, null checks, and all sorts of concepts that capture disjunction or the concept of or. That's why we call this either. It's either or. We can use that all throughout our code. Now let's take another example of finding a color. So here I'll be introducing a method, and we're calling it as find color. We're taking one argument for this as name, and that's what we are putting over here. So if the name that we are passing exists in this array, it will basically give us the hex code of that particular color. Now here you can see we have this from nullable. Now from nullable is basically going to make use of this either left or right. So here you can see we have this from nullable defined. It takes one argument, that's the color that we have, and it's checking whether x is null or not. If it's not null, then we are passing right of x, otherwise we are saying left of null. Now let's see how we can make use of this. So here you can see in our color array we have this blue color, and at the moment we are trying to find that blue color, we are slicing the hash from that color code, and then we are converting it to uppercase, and then we are printing out the result that's from the right. And if I go ahead and execute this now, you'll notice the output as 3B5998, and here you can see that's the value. It's being capitalized and then printed. Now if I go ahead and provide any other color, let's say green, and you can see that green is not part of this array. So we have red, blue, and yellow. Now in case of green, what is this going to print? It's going to print no color, because that's not part of this, and it is going to fold the no color one. That's the left one. So here let's save this, run it, and there you go. It says no color. So what we are doing is we are having this const res, and if it's finding the color that we are providing, then we are going with the right. Otherwise, we are returning left of null. So whenever we are calling this find color method, we will get a right or a left back, and we must wrap over it. And we cannot just get blindsided by a null in runtime if I pass the wrong color. And that's the reason why we are passing green over here and we are getting no color as the output. We are not getting any exception thrown because that color doesn't exist in the array.